Hello everyone, in this video we are just going to interface SSD1306 OLED display with Raspberry Pi Pico. Let's get started. As the first phase of this video, we are just going to discuss in detail about the schematic diagram that we are going to build to interface this particular display with Raspberry Pi Pico W. And let's get started. Now you can see on the screen we have the Raspberry Pi Pico on the left and OLED display on the right. So you can see there are four particular pins in OLED display. One is VCC ground for powering of the display, and the protocol that the OLED display uses is I2C, inter-integrated circuits communication. So it has two different lines, that is it is a two-wire protocol, so it contains SCL and SDA. So we are just going to power up this particular display with the same power source of Raspberry Pi Pico. So I'm just going to connect this particular VCC to one of the 5-volt pin of Raspberry Pi Pico, that is pin number 40 is VBus, and ground I'm just going to connect it to the ground of Raspberry Pi Pico, that is pin number 38. So these pin numbers I am just getting from the datasheet of Raspberry Pi Pico W. If you want to explore this, you can just download the datasheet from Google directly, the Raspberry Pi Pico. And regarding the SCL is pin number 22. So I am just connecting this SCL of OLED to pin number 22, and SDA is pin number 21. So I'm just going to connect it to number 21. So that's all about the schematic diagram that we are going to build for interfacing this particular display with Raspberry Pi Pico W. Let's get started with the MicroPython part. What are the scripts required for running and displaying fonts, characters, etc. into this OLED display. For developing the Python script, I am just going to open the Tony IDE, which we are going to use for developing the relevant Python scripts for interfacing OLED display with Raspberry Pi Pico W. And here I'm just going to create a new file by clicking on File, New, or Control N in my keyboard. And here I'm just going to write a single line. Let's take it to be import mission, and I'm going to save this. Control S. Just click on this computer and move to the respective folder where you want the files to be stored, and then get proceeding with your this thing. Here I'm just going to save it as OLED text, and you can see it is saved in the .py format, which is the official format of Python file. And the next import that I'm going to do is I'm just going to import the pin module from mission module. So I can write like from mission import pin. The next thing that I'm going to import, that is the next module that I'm going to import, is SSD1306, and for timing purpose I'm just going to import the time module. So these are all the modules required for interfacing this particular SSD1306 OLED display. And as the first step, I'm just going to initialize or configure the I2C line of Raspberry Pi Pico. So I can write like, I just want a variable, so I'm just naming it as I2C itself, and I just want to use the mission module to import the capital I2C. So this instance help us to initiate or configure the I2C module of Raspberry Pi Pico. So first parameter is the ID of I2C communication. Let's give it as 0, and the second parameter is the pin number, that is SDA pin number or the data pin of I2C communication. So you can write like SDA is equal to pin of 16. The next parameter is the SCL pin number. So similar way we configure the SDA, I'm just going to configure the SCL. That's it. I2C has been configured here, and the next thing is we just want to configure and initialize the SSD1306 OLED. So for that I just want another variable. Let's name it to be OLED. You can give whatever name you want here or here, but you just want to follow the same variable that you are using right over here. And here you can go with the instance SSD1306 and pointing it to the instance SSD1306 underscore I2C. So this particular instance helps us to configure or initialize the OLED display SSD1306, which is available inside the library SSD1306. And first parameter that you want to set here is the horizontal pixel length of the display. In my case, I am just using 128 cross 64 pixel OLED, so I can give 128, and second parameter is the vertical number of pixels, which is 64 in my display. If you have a display with more number of pixels, just provide the accurate value right over here. And the third parameter is nothing but the I2C variable that you configured right over here. Just follow the same naming that you gave right over here also. And the fourth parameter is the address of the I2C communication device, that is this SSD1306 that I'm having is having the address 0x3C. So this data you can find from the datasheet of SSD1306 display that you are using. Just go to that and find the 7-bit address and you will find that. For the standard 128 cross 64 display, the address is 0x3C. And here I'm just going to use a simple while of true, that is infinite loop, for displaying the font. First thing is I'm just going to fill the display with 0, and next thing is I just want to show you another instance, that is so. So this particular thing will fill the entire display with 0 or turned off, and this particular thing will fill the entire buffer of the display and displays that onto the display. That's all. Displays everything onto that display. That is, here we are filling everything with 0 and we are displaying that here. Without this show function, nothing will be visible in the OLED display. Just make sure you are giving this show function at the end of the programming line. I'm just saving this. I have connected my OLED display to my PC through micro USB cable, and the circuit is built in the breadboard. You can see when I run this, it is running and my OLED display is displaying nothing. So this is expected because we have turned off this particular all the pixels of the OLED display with the turn off 0, and we are displaying it with the show function. Now when I do in the alternate way, that is when I try to fill every pixel of OLED with 1, and let me show that with the show function. Now I'm just saving this. Now when I run this particular program, you can see all the pixels of OLED display is lighted up. So glitch in the display is due to the video frames per second. It is longer than OLED, so that is why it is glitch. But all the pixels will be turned on if you make this fill with 1 entirely. Now I'm just making this 0 as older thing, and after this I'm just going to use the same variable right over here, that is OLED, that is defined right over here. So for all the instances that you want to call inside the SSD1306, you just want to use the same variable that you used for configuring. So same variable that you initialized for configuring, you just want to use. So using this OLED, I'm just going to point it to text instance. So this text instance actually help us to print text onto the OLED display. So I'm just typing like SM Academy is the first parameter, and the rest all the parameters I'm just providing 0. What we are doing right over here is we are just printing this text at X value 0, Y value 0, and inversion set to false. That is inversion meaning whether we want to make all the pixels high for the particular text or low for the particular text. As we saw the fill of 0 and fill of 1, the same thing happens here for this particular text. If you provide 0, it will be turned off, and if you provide 1, it will be turned on. All the pixels will be turned on. That's all. Now I'm just saving this, and when I run this, you can see the SM Academy has been printed on my OLED display. So this is how you can print text onto the OLED display with the help of MicroPython and Raspberry Pi Pico. Now if I want to place the text somewhere else in my display. Let's move this particular x value to, let's say, to be 8 or 8, and this y value I just want to move this to, let's take it to be 10. Now when I run it, what happens here is the starting point of this particular text will be allocated in the row horizontal pixel number 8 and vertical pixel number 10 with the inversion turned on. Now when I run this, you can see the SM Academy has been printed in the respective position of the display. So this is how you can play around printing text in whatever place you want in your OLED display with the help of text function. And when I want to print an inverted text, meaning like now the text is you can see on the display, then now the text is lighted up, leaving all the other pixels of the display turned off. But now what I'm going to do is I'm just going to light all the other pixels except the text part. So let's do that in the same format. As I said, I'm just going to fill everything with 1, which means I'm just going to turn on every pixel of OLED display with the value 1 or the LED turned on, and here I'm just going to provide 0, meaning that this particular text will be printed in the x-axis 8 and y-axis 10 of the display with the inverted format, that is this particular pixels will be turned off, and before that we are just turning on all the pixels of the display so that the visibility will be like all the pixels of the display will be lighted up except the text SM Academy in my OLED display at the location 8, 10. So I'm just saving this and I'm running this by clicking on this particular icon. You can see my SM Academy pixels only turned off and all the other pixels are lighted up. So this is the output which I got in the hardware, and I hope you learned how to interface OLED display with Raspberry Pi Pico W in this particular video, and how to play around with text in OLED display with the help of Raspberry Pi Pico MicroPython scripts. See you in the next video. Thanks for watching.